Okay, so this is for 5.9 from your notes. And what this is about is just determining what kind of polynomial data suggests we should use, and then using it. First thing we're going to look at actually is number 16, which says f of x equals x cubed minus 4x squared minus x plus 1. And what we need is we need a set of data from this equation. And so I'm going to go to my calculator to do that. And I'm just going to type this in. The alternative is to actually pick 4 or 5 or 6 x's, probably about 6 x's or 7 x's that you can plug in for x everywhere you see it, and then build your xy table. The way we're going to do it,
Teachers, please excuse the interruption.
what we're going to do is we're just going to build ourselves an xy table from the calculator to make this a little bit easier, because instead of having to do it several times, we'll just have to do it once. I'm going to turn it on. I'm going to go to y equals, and I'm going to type in x raised to the third minus 4x squared, or raised to the second, minus x plus 1. And rather than I don't even need to look at the graph necessarily, but what I'm really focused on is the table. So I look at this xy table. I'm just going to use the first 7 numbers. So I'm going to start with 0 through 7. 0, 1, 2, 3, 4, 5, 6. That should be 7 numbers. Yeah, that'll work. And then I'm going to go back to that calculator and try to write down these numbers. It's 1, negative 3, negative 9. Negative 3. Whoops. I'm having a problem. Excuse my hand while I fix this mistake. Real quick. Negative 3, we said it was negative 9. Okay. I think it was negative 11. And then after that, let's see what else was there. Turn that back on. Then it was negative 3, 21, and 67. Negative 3, 21, and 67. And the way that we do this now is what we're going to do is we're going to validate that it's a cubic. Okay, I know that you may say, well, I already can tell it's cubic, but how would we know that if we just had the data? We want to validate this idea, and so what we do is we take the numbers from the y values, 67 on the right, and we minus the 1 on the left. 67 minus 21 should be 46. And 21 minus a negative 3 should be 24. Negative 3 minus negative 11 should be 8. And negative 11 minus a negative 9 should be negative 2. And negative 9 minus a negative 3 should be negative 6. And negative 3 minus 1 is negative 4. Now you may look at that list and say there does not seem to be anything special going on. And you're right. To this point, nothing special is going on. So we do it again. 46 minus 24 is 22. 24 minus 8 is 16. 8 minus a negative 2 is 10. And negative 2 minus a negative 6 is 4. And negative 6 minus a negative 4 is negative 2. Nothing too special. Now you might see a pattern emerging here, but there's nothing too special yet. So I do it again. And this time we're going to get something special happening here. 22 minus 16 is 6. 16 minus 10 is 6. 10 minus 4 is 6. And 4 minus a negative 2, sure enough, is 6. What does the fact that they're all 6's tell me? Well, this was the first difference. This was the second. And this is the third. So this tells me that this is a third degree polynomial, because the third time I took the difference in the y values, I got the same thing all the way across. So that's the first part of the assignment. The second part of the assignment works very similarly, at least to start. Okay, so if we look at question number 18, 18 has a set of y values that we're supposed to plug in to y equals, or sorry, that are our xy table. This is again for number 18. And the x information for 18 is 1 through 6. 1, 2, 3, 4, 5, 6. And that doesn't matter so much as what are the numbers down below, which it looks like 0, -3, -8. It's doing it again. Whoops. Excuse me. Did it again. All right, 0 through -3, -8. Then we have -15, -24, -24, and -35. Okay, so what we're looking for is what degree polynomial do we want to use our calculator to find. We take the difference between -35 minus a -24. We always go right minus the left. That's like adding 24 to it. So it should be -11. 24 minus a -15. That's like adding 15 to -24. It should be -9. -15 minus -8. That's -7. And here's -5. Here's -3. Okay, and those are not all identical. So it's not a line. Essentially what we're finding out right now is this is not a straight line because the change is not always the same. So we're going to go after what's called second differences. Well, -11 minus a -9 turns out to be -2. And -9 minus -7 is -2. And -2 and -2. It's important that you don't take the one on the left minus the one on the right. It doesn't work the same. And so we really want to focus on doing it the correct way. So this is the second line, right? So that makes it a second difference. So when we write the equation in the calculator, as we make our list, so we're going to turn it on, we're going to go to Stat, we're going to edit our list, and we're going to type in the numbers that we see for our x values. 1, 2, 3, 4, 5, 6. And then we're going to go over, and in our y values, we'll type the 0, -, whoops, back that up, -3, -8, -15, -24, and -35. Okay, now that we have this data set, we're going to hit Stat, we're going to run a calculation. Now when we were doing Chapter 4, everything we did was quadratic. If it's a third degree polynomial, because it's the third difference, we'd go cubic. If it's a fourth difference, we go quartic. And then, of course, it's a first degree, we would do linear, and I think we chose number 4 would be the one we would choose for linear. Okay, ax plus b, so it's like y equals mx plus b format. But this is a second degree, so first degree, second degree, third degree, fourth degree. We're going to go with quadratic. We're going to run a quadratic regression. And it should come back with this information. This b right here, see it has that e -12? That means I'd have to move the decimal over 12 spaces and put zeros in between the decimal and the 2, which means there's a lot of zeros. And we're essentially going to say that that's a 0. So my answer would be y equals -x squared, -1x squared, plus 1. So y equals -x squared plus 1. And this would be the answer to that problem. Did we know? What if we did it cubic? Could it still give us an answer? Yeah, in fact, if I stat and I run calculation and I do cubic regression, it still gives me information, but look what it does to my A. It's going to tell me that's not okay. That's because these are perfect fits. In real life, most of the time, it's not a perfect fit. And so we have to choose the right regression because they'll all give us weird decimals or strange numbers that we're not always used to seeing in a textbook. We still need to know whether or not they're valid. And we would validate it by which method's the best. Also, if we go to going to clear out my y equals. If I go to the graph and I were to stat plot, so second y equals, turn on my plot, okay, and go to the graph, you'd see some of these points. Well, we're sitting there wondering what's happening here. If I set my window so that my y minimum, because it's got to get all the way down here to negative 35, it's at negative 35, and my y max, whoops, negative 35, my y max is maybe 5, and I count by 2's. And then if I look at the graph, we see this fall off right here, okay? So that's our graph like that. Well, if we were to graph the equation, y equals a negative x squared plus 1, see what happens when we graph it. Sure enough, it fits right through that, okay? And if we try to do a cubic, it would force it to turn and go back up. Okay, we don't want that. We want to have this nice, beautiful pattern, okay? And so that's your homework. Hopefully you can create these equations using your regression. You do have to decide whether it's cubic, quartic, or quadratic, or linear, and hopefully that'll help you get through the homework. Alright, let me know what you need, and we'll see you in class.